Listen, you and me, we need to talk, okay? Today, I'm gonna show you the problems, like the obvious ones, that every model rocketeer will encounter when attempting to use a gimbal thrust vector control approach to landing a model rocket. Before I go on embarrassing myself, I do want to just take a side note here and say I am not an engineer, and if you want to get technical about it, my title might look something more like ambitious YouTuber makes a fool of himself while attempting the impossible on 10th grade math. As a follow-up, if you're new or returning and this is interesting to you, subscribe and leave a thumbs up. Now on to the video. There are two main issues that I found while researching the issues on trying to land a model rocket. The first of which is predicting the thrust curve and the inability to throttle a solid propellant model rocket motor. To demonstrate this, take a look at this very scientific drawing. As you can see, if we were even slightly off on the amount of thrust being exerted over time, then we may end up landing our rocket in midair and then going back up, taking off again. To solve this issue, we need some way to regulate the descent other than the retromotor. My solution to this is to add grid fins to the top end of the rocket that have been designed with concave holes to make them less aerodynamic. And this is going to allow us to change our surface area on the fly to either speed up or slow down the descent of our rocket as needed. The second issue I want to address this video is very closely related to the first issue, and it's addressing the inconsistent burn times on model rocket engine. If you burn our engine too soon, we can end up free falling from an unwanted height, and the opposite is true as well, where we manage to successfully land our rocket, but there's more motor to burn, therefore we take off again and end up having a second liftoff. To fix this issue, I've designed some basically latches that will go underneath the motor. While in flight, they will be barely noticeable with very low mass, but during our descent, I will purposely fire the retromotor late to ensure we don't burn out too soon. Then the grid fins will help to make sure that we descend fast enough to the ground. And after our flight computer can detect touchdown, the latches built into the underside of the rocket will immediately deploy, closing the hole where the motor fires out, redirecting all of our thrust and energy out of the side of the rockets where those latches were previously. I think at this point I've designed it with 3 evenly spaced out vents to ensure the rocket doesn't tip over after landing. Because these latches will be 3D printed and exposed to extremely high temperatures, they will likely have to be reprinted after each flight, unless I can find an insulator that can keep the PLA cool enough to keep it from melting. But it'll work for the time being as proof of concept. Another huge issue I see a lot of people having trouble with is programming their TVC mount. Some overtune, some undertune, and frankly, I think this area is the one that's going to be giving me the most amount of trouble. I have no prior experience coding it with Arduino or working with servos, and right now this task seems unimaginably difficult and overwhelming. So here's the part where I ask for help. If you or a loved one has prior experience in this department, has knowledge to share, or at least a good place to start, I am all ears. Even just a good YouTube video would be great. One that shows how to use Arduino with servos and an IMU. Alright, that basically covers everything I wanted to address this video. If I've done something that you have a question about, or something that you think, why is he doing that? Leave it in the comments and I'll get back to you. My next video should be up within a week or so of this one, discussing more about the roadmap as timelines start to become clearer. I still need help with a name for the rocket and the whole project altogether. If you have suggestions, leave them in the comments. Thank you.